Type 3 Speed Problems. A train covers a distance of 600 km at x km per hour. Had the speed been increased to x plus 20 km per hour, the time taken would have been reduced by 5 hours. Write down an equation in x and solve it to evaluate x. Now here we are given that the distance is 600 km, the original speed is x km per hour and the increased speed is x plus 20 km per hour. Now the time taken with original speed, let us write that as t1, would be distance upon speed, which is equal to 600 upon x hours. Now the second time, that is with the increased speed, we write that as t2 is equal to 600 upon x plus 20 hours. Now according to the given equation, we have t1 minus t2 is equal to 5. So we get 600 upon x minus 600 upon x plus 20 is equal to 5. Now we take the LCM as x into x plus 20. So we get 600 into x plus 20 minus 600x upon x into x plus 20 is equal to 5. Cross multiply. On the right we will have 5x into x plus 20. On the left, open the brackets, we get 600x plus 12,000 minus 600x. 600x minus 600x cancels. We have 12,000 is equal to 5x square plus 100x. Now transfer 12,000 to the other side. The equation becomes 5x square plus 100x minus 12,000 is equal to 0. Now divide this equation throughout by 5 to get x square plus 20x minus 2,400 is equal to 0. So we have got the quadratic equation. To factorize this, we want two numbers whose product is minus 2,400 and sum is 20. So we take the numbers as plus 60 minus 40. So the equation becomes x square plus 60x minus 40x minus 2,400 is equal to 0. Now from the first two terms, x common, we have x plus 60. From the last two terms, minus 40 common, we have x plus 60, which is equal to 0. That is, x minus 40 into x plus 60 is equal to 0. Either x minus 40 is 0 or x plus 60 is 0. That is, x is equal to 40 or x is equal to minus 60. But x cannot take negative value, so x is equal to 40. That is, the speed is 40 km per hour. Now to the next problem. The distance by road between two towns A and B is 216 km and by rail it is 208 km. A car travels at a speed of x km per hour and the train travels at a speed which is 16 km per hour faster than the car. Calculate, first part, the time taken by the train to reach town B from A in terms of x. Second part, the time taken by the car to reach town B from A in terms of x. Third part, if the train takes 2 hours less than the car to reach town B, obtain an equation in x and solve it. Fourth part, hence find the speed of the train. Now, speed of the car is equal to x km per hour and the speed of the train will be x plus 16 km per hour. We are given that the distance between A and B by road is equal to 216 km and by rail is 208 km. Now, the time taken by the train to reach town B from A would be distance upon speed, which is equal to 208 upon x plus 16 hours. And the time taken by the car would be 216 upon x hours. Now, according to the given condition, we have time taken by the car minus time taken by the train is equal to 2 hours. So, the equation becomes 216 upon x minus 208 upon x plus 16 is equal to 2. We take the LCM as x into x plus 16, we get 216 into x plus 16 minus 208x upon x into x plus 16 is equal to 2. Now take x into x plus 16 to the right, cross multiply. The right side becomes 2x x plus 16. On the left we get 216x plus, now 216 into 16 gives us 3456 minus 208x. So the next step becomes 8x plus 3456 is equal to 2x square plus 32x. Take 8x to the other side, we get 24x, and 3456 take to the other side, we have minus 3456 equal to 0. Now we divide this equation throughout by 2 and get x square plus 12x minus 1728 is equal to 0. We have got the quadratic equation. To factorize this, we want two numbers whose product is minus 1728 and the sum is plus 12. So what can the numbers be? 48 and minus 36. So we write x square plus 48x minus 36x minus 1728 is equal to 0. Now from the first two terms, x common, we have x plus 48. From the last two terms, minus 36 common, we have x plus 48, which is equal to 0. So x minus 36 into x plus 48 is equal to 0. So either x minus 36 is 0 or x plus 48 is 0. That is, x is equal to 36 or x is equal to minus 48. But speed cannot be negative. So we have x is equal to 36. Now we are asked, find the speed of the train. Speed of the train will be 36 plus 16, which is 52 km per hour. to our next problem. The speed of a boat in still water is 8 km per hour. It can go 15 km upstream and 22 km downstream in 5 hours. Find the speed of the stream. Now here we are given speed of the boat in still water is 8 km per hour. Distance upstream is 15 km and distance downstream is 22 km. We want to find the speed of the stream. Let that be x km per hour. Now the speed of the boat upstream will be 8 minus x km per hour and speed of the boat downstream will be 8 plus x km per hour. Why is this so? Because when the boat is going upstream, it is going against the current and so the speed will reduce. And when it is going downstream, the speed will increase. Now according to the given condition, we have time upstream plus time downstream is equal to total time. Now what will be time upstream? It is distance upon speed, that will be 15 upon 8 minus x, and time downstream would be 22 upon 8 plus x. So the equation is 15 upon 8 minus x plus 22 upon 8 plus x is equal to 5. Now we take the LCM as 8 plus x into 8 minus x. We get 15 into 8 plus x plus 22 into 8 minus x upon 8 minus x into 8 plus x is equal to 5. Now expand the left side to get 120 plus 15x plus 176 minus 22x. Now take the denominator to the right side. We get 5 into. Now 8 minus x into 8 plus x gives us 64 minus x square. Now left side we simplify as 296 minus 7x. Right side as 320 minus 5x square. Now take all the terms on one side. We get 5x square minus 7x minus 24 is equal to 0. Now we have got the quadratic equation. To factorize this, we want two numbers whose product is minus 120 and sum is minus 7. So what can the numbers be? We can take the numbers as minus 15 and plus 8. So the equation becomes 5x square minus 15x plus 8x minus 24 is equal to 0. From the first two terms, 5x common, we have x minus 3, and from the last two terms, 8 common, we have x minus 3 equal to 0. Factorize this as 5x plus 8 into x minus 3 is equal to 0. Either 5x plus 8 is 0 or x minus 3 is 0. That is, x is equal to minus 8 upon 5 or x is equal to 3. But x cannot be negative, so x is equal to 3. That is, the speed of the stream is 3 km per hour. Now to the next problem. A plane left 30 minutes later than the scheduled time and in order to reach the destination 1500 km away in time, it had to increase the speed by 250 km per hour than the usual speed. Calculate the usual speed. Let the usual speed be x km per hour. So the increased speed will be x plus 250 km per hour. Now we are given the total distance is 1500 kilometers. So the usual time taken will be distance upon speed, that is 1500 upon x. Now the increased time will be 1500 upon x plus 250. Now the required equation becomes 1500 upon x minus 1500 upon x plus 250 is equal to 30 minutes. Now we convert 30 minutes to hours, that is half an hour. Now take the LCM as x into x plus 250. We get 1500 into x plus 250 minus 1500x upon x into x plus 250 is equal to half. Now simplify the left side as 1500x plus, now 1500 into 250 gives us 3,75,000 minus 1500x. Now take the denominator to the right. We get x into x plus 250 upon 2. Now transfer this 2 to the left. So the equation becomes 2 into 3,75,000 equal to x into x plus 250. Now solve this. 2 into 3,75,000 gives us 7,50,000 is equal to x square plus 250x. Now take that to the other side. X square plus 250x minus 7,50,000 is equal to 0. Now we have got the quadratic equation. Now we want two numbers whose product is minus 7,50,000 and the sum is plus 250. What can the numbers be? 1000 and minus 750. So the equation becomes x square plus 1000x minus 750x minus 7,50,000 is equal to 0. From the first two terms, we have x common, left with x plus 1000. From the last two terms, minus 750 common, left with x plus 1000 is equal to 0. So we write this as x minus 750 into x plus 1000 is equal to 0. Either x minus 750 is 0, that is x is equal to 750, or x plus 1000 is 0, that is x is equal to minus 1000. But speed cannot be negative, so x is equal to 750, that is the usual speed of the plane is 750 km per hour.